Good afternoon, good evening, and a very early good morning to everyone who's joining us from around the globe, even those of you for whom it is tomorrow. My name's Edith Wilson, and I'd like to welcome everyone to the fourth and final session of the Critical Minerals webinar series hosted by the Society of Economic Geologists. Before we begin this fourth and final session, and Deanne, I think we're 2 slides too early. Can you go back a couple of slides? Thank you. Before we begin this fourth and final session of the Critical Minerals webinar series hosted by the Society of Economic Geologists, I'd like to, in which we're going to close the loop on the critical minerals supply chain. We have a few bits of information to share with you from the Society. For those of you who are not yet members, we encourage you to investigate joining. The Society of Economic Geologists is an international scientific association, and our members come from industry, academia, and government institutions, creating a unique and diverse network of professionals. Member benefits include community connections, education, training, scholarly publishing, and conferences. And we also provide over $500,000 annually in student support and have over 100 student chapters in 31 countries. Next slide, please, Deanne. If you're already a member, you can also earn reductions in your membership fee by encouraging others to join. So if you see someone who's not a member in the participants list today that you know, reach out to them and refer a colleague. More information on this program, as always, is on our website at segweb.org. May I have the next slide, please, Deanne? Welcome everyone as we now begin the fourth and final episode in our critical minerals discussion series entitled Circular Economy, Building a Resilient Supply Chain by Planning for Reuse and Recycling. I'm Edith Wilson, and I'll be moderating today's discussion, which is hosted by the Society of Economic Geologists, an international scientific association devoted to advancing the science, discovery, and responsible development of the materials that build our world. Please note that today's webinar is being recorded and will be available to the public on the archived event page of the SEG website, as well as on the SEG YouTube channel. May I have the next slide, please, Deanne? Before our panelists introduce themselves, I'd like to extend a special welcome to our students and early career professionals. We hope that these discussions with inspiring leaders in the energy transition and this in-depth look at the circular economy will continue to generate ideas about opportunities in our new energy economy. Our first order of business is a quick poll of participants through which we gather a little bit of demographic information. So if you would please, we'll bring up the first poll question. Feel free to answer each question as it comes up. So Duncan, let's begin. The first question is, which best describes where you currently are in your career? And panelists, you can answer these questions as well. The next question is, please select your appropriate age range. What geographic region are you based in? What's your current employment status? And then finally, we'd like to know how many of you have been with us for more than one of these series events. So please answer the fifth question, which is, how many of the SEG Critical Minerals Series webinars have you attended in 2021? Once, and I see the panelists cannot vote, my apology, but all of the participants can vote. Once you have answered all the questions, please just click submit and we'll begin to see the results very shortly. I'd like to take this opportunity also to remind you that you can post questions in the Q&A function of Zoom at any time. And if you would, please reserve the chat for any technical difficulties or any specific questions to the organizers. And in the Q&A, be sure to upvote if your question's already been proposed. And that way, we'll be able to determine how much, what the order of priority of questions are. So in just a moment, we'll see the results from the participant poll, and we'll take a look at those and then continue with the webinar. There we are. Okay, so our poll tells us we have a bell curve, a normalized curve of different kinds of experience levels with a bump at industry professional. In terms of an age range, we have a nice spread over the entire demographic perspective. We are North America heavy, as is often the case, but we have a number of friends joining us from Friday morning. Welcome to all of you who are up early having your first cup of coffee. And we are looking at a range of academics, employed professionals, retired, and those who are looking at new opportunities. This day is for you. We have a lot of you joining us for the first time. That's good to know. And welcome back to all of you who have participated in other seminars before this one. Thank you so much for helping us to collect these data. And at this point, I'd like to take a look at the next slide, please, Deanne. We're going to end as we began in considering the entire critical minerals supply chain from start to finish. Our earlier episodes dealt with mining and with processing in some detail, and today we're going to add to the mix a consideration of this unique opportunity that our new energy storage devices allow for reuse, repurposing, and recycling of components. How are we going to change our language from cradle to grave to cradle to cradle and close the loop for battery materials in particular? Deanne, the next slide, please. So as a reminder in this slide from our last seminar, the energy transition is about much more than just switching resources from fossil fuels to wind and solar. Instead, it's fundamentally a change in how we store energy that's captured from the sun. For millennia, we've used hydrocarbons, first wood, now oil and gas, and these storage devices were the most efficient ones we had in their day, but to use them, we had to destroy them. Now we're moving towards storing energy in batteries, which are not destroyed upon use, but whose components can be repurposed and recycled. We need to be purposeful in our design and implementation all along the way so that we can maximize the use of every ounce of critical material. So we've brought together today a panel of explorers, entrepreneurs, business owners, inventors, academics, and visionaries who are engaged in doing just that. So with that, I'm going to ask each panel member to introduce themselves, to tell you their story. And as they speak, again, feel free to post your questions in the Q&A function. We'll sort through them and begin answering them after we've learned a little bit more about each of our panelists. So if I could have the next slide, please, Deanne. We're going to begin with Anita Papakar, Fox, excuse me. Anita Papakar Fox from the University of Queensland. And Anita has made her personal journey from one end of the supply chain to another. So good morning, Anita, take it away.
Hi there. So yeah, thank you for having me today on this panel. So indeed, my name is Anita Papakar Fox. I grew up in the UK and I studied geology at the Royal School of Mines. And the subject that I read there was environmental geology. And I suppose even then I was a bit of an odd one because there wasn't many actually sort of studying environmental geology per se. But the thing that really got me into environmental geochemistry was I did a project where I learned about arsenic contamination in the Bangladesh aquifers and the impact that had on human health. And to me, that really kind of kick-started my interest in kind of understanding how, the impact of metals on sort of human health and sort of, I guess, that was really what kick-started that relationship with understanding mineralogy and contaminants and its migration in the subsurface. So after I completed my undergraduate degree, I moved to Tasmania after a stint in contaminated land in London, which was perhaps a little bit limiting in terms of really sort of getting into depth in terms of working in challenging environments and really putting into practice the things I'd learned in my undergraduate degree. So I had the opportunity to move to Coates down in Tasmania, where I sort of served sort of quite a reasonable stint down there. I was researching into acid rock drainage prediction in the mining industry. So I was really looking at the integration of geometallurgy and sort of those types of techniques into how we could better improve our understanding of ARD formation and actually improve how we predict it. So really the key was integrating more mineralogical techniques into that prediction chain. And so that kept me busy for a couple of postdocs. And then eventually I moved up to the SMI here, the Sustainable Minerals Institute in Queensland, where now I have the opportunity to not only characterize these materials, but to actually start to think about how we can reprocess these and pull out those critical metals that we so desperately need as we move towards this energy transition that as a global community we're striving for. So I like this picture here, how it started and how it's going, because I seem to have really traded in the bucket for bags now and upgraded my little shorts there for some proper PPE. So seem to have come full circle in that regard and sort of sticking to playing on beaches, of be it a natural beach or a tailings beach. So next slide, please. Perfect, there we go. So I guess I just wanted to share kind of, the diversity of what I do in my current day job. So I love my job because I have the opportunity to go out to lots and lots of sites. So where that little arrow is, you can probably see me standing there amongst the waste rock and the tailings. And so every single site we go to is completely different. So I think that's one of the things that I love. Like, people sort of assume mine waste is this homogenous thing. It completely isn't. Like, so many different things and processes, and obviously the mineralogy really influences what we see at all of these different sites. But it's, I suppose it's not just the sort of taking the bags, going out sampling and making observations. Sometimes I've had the opportunity to do some pretty wacky things too. So here is myself and my colleague Laura Jackson, and we were down on a site in Western Tasmania where, we had the opportunity to sort of abseil down and sort of collect waste rocks. So some
Have we lost Anita?
Sometimes the job can be quite physically challenging, but it's... Sorry, yeah, no, I was just saying that one of the things that I've always really enjoyed about my career was the opportunity to teach. So when I was at the University of Tasmania at Codes, I was the unit coordinator of the environmental geology unit, and I absolutely love that kind of knowledge transfer, because every new geologist, be it someone who's going to work in exploration or mining, needs to have a good understanding of the environmental impacts of mining and sort of understanding that ARD prediction. So, not only sort of amongst the undergraduates, but I've also enjoyed the opportunity to do outreach, both at schools and also to my own kids, who unfortunately have been dragged out to many field trips with me in their summer breaks and sort of had to muck in and help sampling where's appropriate. So for me, just to sort of conveying the importance of redesigning what we do with our mine waste and seeking those opportunities to valorize is really an important thing. And it's something that I'm keen to push on as I sort of move forward in my career. So that's probably enough for me for now. So thanks, Edith.
Thank you, Anita. That was lovely, and love all those pictures in the field. Today, with our next slide, we're thrilled to have a real life example of this wonderful mentor-mentee relationship that we've all benefited so much from. And so allow me to introduce Anita's PhD candidate and advisee, also a mining geologist and explorationist in her own right, Lauren Nichols.
Hi, thanks Edith, and hello everyone from the land down under. I'm also in Brisbane with Anita, and she is my primary supervisor for my PhD. So my background is in exploration and mining geology, mainly for traditional commodities such as gold, silver, copper, lead and zinc. And since graduating from the University of Queensland, I've spent the last 10 years working on both brownfields and greenfields projects around Australia, Fiji and Indonesia. And you can see in the first 6 photos on the right that I spent a lot of time logging core, mapping, getting incredibly drenched from hiking up creeks in the jungle trying to find outcrops, being chased by bulls in different paddocks. I've also spent a bit of time making friends with boggers underground and sweltering in open pit mining in the desert. So I guess for me, it was really when I hit my 30s that I began to reevaluate where I was heading in my career. And while I truly loved my job exploring for gold and copper in remote parts of the world, I also had a really keen interest in the greener side of things, in green technologies, in mining rehabilitation, in critical metals, in the circular economy. And so I decided to follow a new direction this year and start a PhD with Anita. But I guess when I was working in the industry, I never really considered that 1 gram of gold, which is essentially the size of my little fingernail, would actually generate 1 ton of waste material. It's a huge amount of material to store and to manage. And if we don't manage it properly, then we're going to cause widespread environmental and social damage and also pose huge financial risk to the industry. So what if we could apply circular economy principles like the recycling, repurposing, and reusing of this material and get something of value from it? What if we could secure an ethical and stable source of critical metals from it? And so I guess this is where my interests merged into a PhD, which is my topic is looking at the secondary prospectivity of Queensland's mine waste as a source for cobalt for batteries and EVs. And while we're processing this material, we might just be able to make a benign secondary waste product that will have a much smaller environmental footprint and be easier to manage in perpetuity. So as I'm sure you all know, reprocessing of tailings is not a new concept. It's being done around the world for many years. However, it's not considered a mainstream approach to waste management because our industry is still so linear in its approach to mining and not circular, as we're talking about today. So I'm hoping to play my part in making the industry bend a little bit. And I guess in my mind, I'm still an exploration geologist. I'm just exploring a different host for critical metals that might actually make a difference in minimizing our environmental footprint. So that's me.
Excellent. Thank you so much, Lauren. That's fascinating. And it's wonderful to look at that aspect of doing things differently along the mining waste side. Our next panelist is Grace Snyder Hansen, and we can have the next slide. Thank you. Grace is with American Energy Technologies Company, and she's on the front lines with her hands on all aspects of reusing and recycling the components of spent lithium-ion batteries. So Grace, tell us about yourself.
Hi, Grace Snyder Hansen. Super excited to be here. Yeah, so I studied material science and engineering at the University of Minnesota Twin Cities, and I actually graduated just this past May. So I suppose you could say I'm an early career professional. Yeah, so I've always really enjoyed working with my hands, and I wanted to do some lab work. I was interested in working with batteries. So I started working at American Energy Technologies Company as a materials scientist. AETC is a company that does material testing, R&D, and manufacturing with a focus on industrial carbon and graphite. And day to day, my job is a lot of material testing of graphitic material for application in batteries. And in this particular picture, I'm preparing a sample for a viscosity test. So if we want to go to the next slide. So yeah, I'd like to go over a little bit of kind of what AETC does in relation to recycling and reuse. You may or may not be aware that a lot of recyclers of lithium-ion batteries tend to focus on the nickel and the cobalt as high-value materials rather than graphite, when graphite makes up anywhere between 15 to 25% by weight of a battery. And meanwhile, cobalt and nickel tend to be closer around 7%, although that's highly dependent on the chemistry of the cathode. And there's even a lot of research being done on limiting or even completely eliminating the amount of cobalt in batteries. And so cobalt is around $66,000 per ton, nickel about $20,000 per ton, and the battery-ready graphite is around $20,000 per ton. And so if you think about how much more graphite there is, then it really should be paying more attention to recycling of graphite because it would be profitable, and also it would reduce our dependence on graphite from China. So for the pictures, the image in the upper left is black mass from lithium-ion batteries, and that is shredded material from spent batteries, and it's made up of carbon black, fragmented graphite, as well as other various metals and materials. And the picture below that is a loss on ignition test, which measures the impurity, the carbon content of the black mass. And the purity of a graphite to be used in batteries must be at minimum 99.95 weight% carbon. And so you can see from all these impurities we're not anywhere near that. So the black mass series of processing, which includes thermal purification and then spheritization. You can see the center image is an SEM image of recycled battery-ready graphite, and that's what it's supposed to look like, more spherical, elliptical. And so there's all this processing that needs to happen. And then the image to the far right is a continuous fluidized bed reactor that AETC has developed. Material goes in at the top, and then we heat it really high temperature, purities sublime and come out. And so while we are purifying the graphite, we're also collecting the impurities, and from there we can extract very valuable metals like manganese, cobalt, and nickel. So right now, graphite is the dominant active anode material in lithium-ion batteries, and that's not going to be changing anytime soon. And so I think with this growing demand with lithium-ion batteries, the market, we should really be paying attention to all the materials inside of the lithium-ion battery to be recycled.
Excellent, Grace. Thank you. We won't waste a drop. This is awesome. So finally, I'd like to welcome our panelist, Alex Grant, and ask him to tell us how he's explored from one end of the supply chain to another, from lithium processing to life cycle assessment. Alex, over to you.
Hello. Thanks for having me. So yeah, I'll just kind of give you a rundown on my story. So I'm a Canadian national, grew up near Toronto, did my undergrad at McGill in Montreal, studying chemical engineering and philosophy. In undergrad, I was mostly doing research in wastewater treatment and water chemistry at the university, at startups in Montreal, in Switzerland, and Mexico City, but kind of got tired of cleaning up other people's messes since no one wants to pay for wastewater treatment. So I went for a PhD in chemical engineering at Northwestern in Chicago to study CO2 heterogeneous catalysis conversion to methanol and other kind of small chain hydrocarbons. But well, you know, in 2 years there, I built a high temperature, high pressure catalysis reactor, you know, spent $250,000 on a gas chromatography machine, set everything up, and that whole instrument is now used for scientific studies. But I realized that there were some kind of thermodynamic issues with that energy technology platform concept, and realized that the lithium-ion battery was a significantly better idea for storing energy for most applications of energy storage. So I dropped out of my PhD with a master's, and I co-founded a startup called Lilac Solutions, which is a lithium extraction technology company that brought me to California. That company has just closed their Series B a month ago. They raised $150 million from Lower Carbon Capital, Breakthrough Energy Ventures, the Bill Gates Fund, BMW, Sumitomo, T. Rowe Price. So they've got like really awesome cap table now. So very proud of helping start that project. But I left about 2.5 years ago, started consulting independently across lithium. So we're working with project developers, trying to make lithium chemicals from natural resources, working with investors, doing diligence on projects and technologies, working with technology companies, working with all different types of folks to figure out like, what are the types of new technologies that we need to deploy to reduce the environmental impacts of making lithium chemicals from lower grade, less pure natural resources like oil field brines, geothermal brines, sedimentary clays, kind of asset classes that have historically not been developed because we didn't need lithium. That brought me to start collaborating with a company called Minvaro in London, who does life cycle assessment of mining projects. So we started working together about 2 years ago, and we published the first LCA ever of lithium hydroxide manufacturing from natural resources that became an industry benchmark. Yeah, just to kind of summarize what that is, it's more or less kind of carbon counting is one aspect of what we do, but then also making quantitative comparisons of water use and land use for different types of projects and different types of products. Like every lithium hydroxide product has a different impact depending on how it's made. So we've now done probably 15 to 20 different life cycle assessments of different natural resource projects all around the world. We have by far the biggest database of the CO2 emissions associated with making lithium chemicals of probably anyone in the world. And the reason why we were able to do that is because we combined like real understanding of the metallurgy and the hydrometallurgy with best practice, like super high quality academic life cycle assessment methodology, and put that together. And I'm still not aware of anyone else in the world that really truly has both those competencies. So yeah, super proud of that product we developed. It's resulting in a lot of business right now. Yeah, so that's a lot of what I do, and also, yeah, that's most of what I'm doing now. So
awesome, Alex. Thank you so much. I'm probably gonna pick on you for the first question, since something you said sort of piqued my interest. But before we do that, let's leave the slides and come to a panel discussion format, please, Deanne. Perfect. Okay, great. So now everyone can see each other's smiling faces, and glad to see, Alex, that you also got the Wear Black and White memo today. We really didn't plan this, folks, but so the first thing I'd like to ask you, Alex, is what new technologies, since you've been sort of at the forefront of developing new techniques and technologies, what new technologies do you see on the horizon, or just a glint in someone's eye, that's going to help make recycling of battery components in particular more commercially attractive?
So first of all, let me say a spiel about battery recycling. The challenge ahead of us for preparing lithium, nickel, cobalt, graphite materials to make lithium-ion batteries over the next decade is not a recycling problem. Let me repeat, recycling will not result in the supply chains we need in the next decade to make all the batteries we need to decarbonize transport. I'd repeat a third time if I thought it was tactful. There is tremendous amount of hype around recycling, way too much focus on it. Recycling is extremely important for processing scrap from battery manufacturing, which represents maybe 10% of plant's capacity, but it is 90% irrelevant compared to what people think it's relevant for. All of the environmental impacts that will be incurred in the battery supply chain will be in natural resource development in the next couple of years. And if your true mission is to eliminate environmental impacts from the battery supply chain, which is my mission, then you should be working on natural resource development, not recycling. There are already tons of people working on recycling, tons of smart people too. That's the worst part, because there's so much competition. In natural resource development, there's not that many smart people, so there's way less competition. So yeah, if your mission is to like make the world a better place, you should be working on mining and intermediate chemical processing. So that's my so sorry, I don't even remember what you asked. I just wanted to talk about that.
No, that's great. I'd like to ask the same question in a slightly different way of our other panelists, starting perhaps with Anita. What about new technologies you see for Anita or Lauren, or both of you, for improving development of metal supply from mine waste? What new technologies do you need to see?
To go first? Or,
sure.
I guess in terms of new technologies, I mean, I agree with Alex's point there in terms of, obviously recycling of waste material is obviously an opportunity to supplement the demand that we need moving forward, and not necessarily replace. And I think there can be a misconception in terms of what the mission is, but certainly is that supplementing. In terms of new technologies, I mean, certainly if we're talking about lithium, I know that sort of out of Western Australia, where obviously the lithium industry has been going off its chops, as it were. There's been new technologies to look at recovering the fines from, I guess, the mining and the processing of lithium pegmatites and things like that. So people like Lithium Australia have sort of coupled up with ANSTO to develop new technologies to recover those fines and actually recover some of that additional value from the tailings. So I guess there are new technologies, and I think they've got a process, I think it's called Lena or something like that. But there are these new technologies coming online to try and recover that value in the lithium space. But certainly in my particular main focus has been around cobalt and sort of trying to recover the value of cobalt from mine tailings and other mine waste streams. And I guess the reason things like cobalt have particularly piqued our interest is because in our research thus far, we see that the cobalt's very much coupled with things like pyrite and some of the sulfides, which are going to form acid. So in order to recover that value, we've got the opportunity to environmentally de-risk that mine waste material and sort of break that source pathway receptor chain of ARD formation. In terms of new technologies to recover that value, I mean, certainly we've been developing some new hydromet processes and sort of other sort of low or greener energy technologies to recover that value. Very much looking at things like, targeted bioleaching. You know, can we use the indigenous bacteria to sort of accelerate the ARD formation process and actually wipe out break down the pyrite and recover the cobalt from the pyrite? So that's kind of one example. You know, we've been looking at in situ recovery technologies, and there's sort of things that are sort of currently being developed, and they've obviously been discussed a lot in the literature. And obviously there's examples of that sort of being actively done for primary ore, but actually applying that to mine waste can be sort of the next challenge. But I suppose the thing that's complicated is that when we start poking around with environmental, you know, sites or sites of environmental interest which have ARD associated with it, then we sort of come to sort of having to consider what the regulators and the legislators might sort of impose in terms of risk. So there can be some reluctance in terms of, you know, actually getting into a site and undertaking that valorization, because there may be sort of residual implications in terms of how the environmental bond may be administered. Or so I guess there's, you know, the whole thing around sort of, it's not just about the technology, but we have to consider sort of the social and the political factors sort of start to come into play. So yeah, I guess that's just a few things to bring to the table, and I'll pass on to Lauren.
Yeah. And Lauren, if you have anything to add, I also have another question for you in a minute, but anything maybe looking a little further down the road, 10 or 20 years from now, do you see some new technology that is on the horizon?
I mean, there are a couple of things. So obviously, like, as Anita said, the mineral processing aspect is particularly key for not only secondary products such as the mine waste, but also for the primary mining of these materials, to be able to get better recoveries and be able to get more value from the material that we're bringing out of the ground. And there are all sorts of different companies that are involved in things like that have come up. I think there's a real space for sort of small to medium scale mineral processing groups to be able to jump in and apply these new metallurgical technologies. A lot of companies are creating proprietary flow sheets to be able to valorize waste material, but also get more value from the in situ material in the ground. But I did just want to actually say something about the recycling of lithium ion batteries. I was doing some reading, and in 2020, the CSIRO, which is Australia's national science agency, and the Future Battery Industries, CRC, published a comprehensive review of the status of lithium-ion battery recycling in Australia. And it actually showed that only 2% of Australia's lithium-ion battery waste is being recycled at the moment, which is a very small number. And they reckon that if recycled, then 95% of these components can actually be turned into new batteries or other industries. So what this report did was it provided some recommendations for opportunities to be able to improve the recycling of lithium-ion batteries in Australia. And a lot of this centered around like government policies to incentivize recycling, and also investment into research of new technologies and improving the battery value chain. But I think the one thing that I found really interesting was that public education was a really important component of this, that things can't be recycled unless the public and private sectors are on board with the batteries. And I was reading a battery book by the founder of KDEX in Vancouver, that the key limiter in recycling lithium-ion batteries is actually the low yield of the material that's provided. And that this doesn't cover the costs of the collection and the transport and the sorting of these battery chemistries and how to actually recover the metals in them. So yeah, I think public education and the private sector education and government incentivization of recycling is really key to being able to encourage recycling in the industry.
Yeah, and I hear and agree with both sides of the argument that for the next decade, we can't at all count on recycling, but ultimately, what do we do with the spent materials we generate? So along those lines, Grace, I mean, what are your thoughts? I sort of think of what you're doing with graphite at AETC as almost being more repurposing than recycling, but what are your thoughts on that particular component and the story it has to tell for this question? Oh. We've lost Grace. She's going to show us something in the lab. Okay. I'm going to go on to another story. It looks like Grace has had to make a move. So I'm going to go on to another question and we'll come back. Grace, are you ready to answer or?
Sorry, I got kicked out and had connectivity issues, so I had to move locations.
That's quite all right. I'll come back to you later. I'll give you a chance to set up. So what I'm going to ask, the next question I'm going to ask of all of our panelists is, if as you look out, and I'm going to start with you, Lauren, because this is sort of where you are right now, as you look out on the horizon and you think about exciting opportunities for geoscientists, especially graduating students, early career professionals, what do you think are the most exciting opportunities in the entire critical minerals supply chain today? And I'm going to ask this of each of our panelists. I'm going to start with Grace and then I'll move along. I'm going to start with Lauren, excuse me, and then I'll move along.
I mean, goodness, the opportunities are really endless. There are so many projects out there to work on. I know our team is growing at lightning speed and the projects are coming in thick and fast, so there's never a dull moment. All you have to do is put on like your Google Scholar alerts for circular economy, battery metals, green technology, and you'll get a daily deluge of articles that are published overnight in the space. So yeah, there's heaps of opportunities both in industry and academia and government, I guess, to be able to work in this space. But I think the thing with early career and emerging geoscientists is that we actually have a really different skill set to the older generation of geoscientists. There's a lot of more knowledge now in AI and programming and machine learning. And so the opportunity to innovate is really quite endless. Geoscience is becoming redefined and requires much more integration across different disciplines. So from my personal experience, I mean, I'm applying more traditional geological skills to be able to characterize the mine waste and identify reprocessing opportunities. But within that, there is a whole team of people supporting me, including enviros, metallurgists, microbiologists, engineers, software gurus, geophysicists, and they're all involved in my geoscience work. So I guess what I'm saying is that now you don't really have to be a traditional geoscientist going through the typical degree. You can come from any number of fields with any number of skills, and there is space for you to be able to innovate and make a difference in the critical metal supply chain. You just got to have big ideas and think big, but there's funding there for anyone who wants to get involved.
Right, I'm going to put everyone's LinkedIn contact information, by the way, in the chat in just a moment. I'm going to ask this question next of Alex, but before I do, I want to remind all of our participants, and I see some very familiar names out there and some new friends as well. Please be sure to put your questions in the chat. And I just saw one pop in that's also on my list, so that'll be my next one. But first, Alex, if you were to meet an emerging geoscientist at, for example, a house party at PDAC, perhaps, what would you think would be the most exciting thing that a geoscientist could do to impact the supply chain?
Geoscientist. I mean, working for juniors is pretty fun. I don't know. I don't know how to answer that question.
Okay, I'll move on. How about you, Grace? You're a materials scientist, not a geologist, but you know some geologists. What do you think would be a fun thing? What would be an exciting opportunity for a geoscientist in this space? And then I'll ask Anita.
I mean, I just think that there are so many opportunities across the entire line that, I mean, you could do almost anything and it would be, I think, an exciting opportunity. So yeah, I mean, there's.
Okay, Anita?
Specific.
Sorry, that's okay. If you have thoughts later, come back to us. Anita, your thoughts?
Yeah, I mean, I guess I've had the privilege of teaching a lot of new geologists coming through. And I guess like from a money and a funding point of view, it's been a really interesting time. So I guess I started in this field in 2006. And back then people were concerned about things around sort of mine waste and sort of I guess more the environmental sides of mining, but you know, it was there, but it wasn't quite where it is at right now. I suppose after the Brumadinho failure, things really changed in terms of people putting a lot more importance on the ESG factors around mining. And so if you do look at the Ernst Young sort of risks in mining that are published every year around sort of end of September time, you know, in the past few years, things like social license to operate have been the #1 sort of factor. And in this, like last year, you know, license to operate, decarbonisation and environment and social were the 3 top risks. And it's quite uncommon, I would say, sort of looking back over the past decade of these risks being published, for such environmental things to focus or to be focused at sort of in the top 3 spots. But certainly what we're seeing is as the new students and the new workforce coming through, we do have a greener generation on our hands. So I mean, certainly the iGens and the Alpha Gens after them, you know, they really are sort of a bit more engaged in terms of thinking about sort of sustainability and, you know, greener mining. I do get the opportunity to do a lot of outreach, both sort of at undergraduate level and even younger, and sometimes even older. And it's really actually great to see people understanding that their skills as geologists can be applied in kind of this battle against climate change. I remember when I was 17, I was sort of choosing what I wanted to do for my degree. And I really wanted to be a climate scientist. I guess I didn't take maths and physics, and so I didn't go in that particular direction. So now, as an older woman, it's quite nice to know that actually the skills that I've got actually will contribute to that war against, or that war on climate change, and sort of be a part of that decarbonisation future. So I think a lot of geologists now are really sort of appreciating that they do have skills that are actually very important sort of to move towards that sustainable mining goal and that zero waste goal, and also that fight against decarbonisation. So, and as Lauren sort of put very nicely, it's not just the traditional geological skills anymore. We have people working in, you know, image analysis to kind of, you know, look at those drill core kind of scanning patterns and maps and et cetera that come out, pull out sort of environmental indices and think about sort of, you know, building safer waste rock dumps in terms of environmental footprints and so forth. So yeah, it's great. Yeah.
So while we're on that subject of trying to stay below 2 degrees of warming, I'm going to throw this one to you, Alex. I know you'll give me a very definitive answer. Does the world have enough lithium, cobalt, and graphite to make all the batteries we're going to need to stay below 2 degrees?
Yeah. There's definitely like physically like enough like atoms in the Earth's gravitational well. Like they're out there, you know, and they're out there in economic or almost economic concentrations and quantities in various deposits. But that's not the right question, right? Like the right question is more like, you know, where are these deposits? How much does it cost to develop and, you know, make the right products from them? What are the right products? Like in the lithium context, there's a number of different compounds you might want to make, and people might have different priorities depending on how they think the market will evolve of which compound they'll make. You know, what are the environmental impacts of making the product at that place? You know, where is it, right? Because developing a mineral project in different jurisdictions is, you know, radically different depending on where you are. And figuring out all those things just takes a lot of time, right? So we're in a lithium shortage right now, for example, mostly because people just weren't making investments 5 years ago, or at least non-Chinese people weren't. And that's going to persist for a couple of years probably. So yeah, the question's more like, how do we build these projects? Where do we build them? Who's going to build them? And what do they look like? Yeah, the lithium's definitely out there.
Okay. I want to come back to you, Grace. Are we connected again well?
Yes.
We are. Okay, great. So I'm going to come back to you with the question that we've heard some really interesting different perspectives on, and then I have a follow-up from one of our participants. But the question to you is, as a material scientist, I know you're not a geoscientist, but as a material scientist, what do you think are some of the new technologies that are going to be really important to this whole philosophy of maybe not recycling in the next decade, but repurposing materials, finding new ways to use old materials? What do you see from your perspective of what you guys are doing with graphite as being some need for new technology development?
Yeah, I mean, we are working on multiple projects when it comes to the graphite, different chemistries, and I guess, and not specifically to graphite, but with carbon, I think there's a lot of cool technologies when it comes to taking carbon from CO2 and then repurposing the carbon. We have one client, Sky Nano, who makes carbon nanotubes out of it, amongst other products. So I think that there are a number of really cool things that are happening. Does that kind of answer the
Yeah. So just to make the point that it's not just about recycling lithium from lithium ion batteries into the supply chain for lithium. There's reusing in different ways and repurposing. And I think you guys are doing a lot of really neat work at ATC in that regard. Again, sort of in this world of carbon reduction and decarbonization, and looking at ways to do that, reusing the carbon for one, for sure, but also what about using mine waste or material waste to sequester carbon dioxide, the sort of other, the denominator of the equation. Does anyone have thoughts on that, on how material waste in the supply chain or mine waste in particular can be used to sequester carbon dioxide? I'll take a raised hand or I'll pick on somebody.
I mean, I can give something here. I'm not going to pretend that I'm an expert on carbon sequestration at all, because it's definitely well out of my field. But I did read something the other day. It was in Economic Geology by Jessica Hamilton. I think it was a 2020 paper. And she was essentially, and I hope I get this right, but she was conducting lab-based column experiments to accelerate the carbonation of ultramafic mine tailings, which could ultimately be used to sequester carbon dioxide. And so while these experiments were lab-based and they need to be upscaled to the field scale, she trialed two processes. She subjected the material with synthetic flue gas, and also she did repeated heat bleaching simulation. But both of these produced really successful results in significantly increasing the carbon dioxide capture. And the other really cool thing about this is that their synchrotron studies revealed that base and critical metals actually appeared to concentrate in the secondary iron hydroxide minerals that precipitated at the pH neutralization boundary in the columns. So again, it's conceptually resolving two issues with one solution: carbon dioxide sequestration and metal enrichment and recovery, which was really, really cool.
Yeah, fascinating. And you know, I'm going to pose a question to everyone that came from one of our first panelists in this series. But I want to preface it by saying a couple of times people have referred to, I've read or I've seen a paper or I've seen a study, and I just want to say that for understanding this new economy, reading something different, you know, if you're a porphyry copper geologist or if you're an oil and gas geologist, reading about solar utilities or reading about mine waste is an absolutely fascinating way to expand your horizons. So, but there's been a comment from Murray Hitzman, who was one of our first panelists, and he's noted that, you know, Alex is saying mining is the most exciting and important job in the space. And, you know, Anita, you're talking about novel mineral processing. Grace, you're talking about making carbon nanotubes, and Lauren's talking about CO2 sequestration. How do we convince more young emerging geologists that these areas of metallurgy, of sort of the edges and frontiers of economic geologists, how do we convince people that these topics are really important to decarbonize the world, rather than the sort of old areas of study that economic geologists are working on. You know, what can we do to make sure that everyone is aware of these fascinating opportunities that are out there? I'm going to ask you all to give me a quick answer to that one, and then I'm going to call on Alex to give his final word, because I know he has to leave at the top of the hour. So Anita, go for it on this one.
Yeah, I mean, I guess there were some really significant articles that have come out this year. Certainly, I know that I don't expect younger children to be sort of reading Nature per se, but you know, Richard Harrington, he released an article in Nature which kind of talked about the green economy, and certainly sold kind of the vision in terms of the importance of the roles of geology and geologists in terms of, I guess, decarbonisation and moving towards that. But I guess the good thing is that when you publish an article like that, it gets picked up by, you know, things like the BBC, the ABC, you know, the American networks, etc. And I guess that sort of messaging gets out, which is like for sort of a national or an international scale kind of messaging and positioning the importance of the role of a geologist in terms of decarbonisation was quite good. I think back to my own education, you know, certainly I grew up in the Thatcher era, and, you know, aspects of recycling and the hole in the ozone layer, that was sort of big news. And we kind of were very green in terms of our education and our thoughts as children. I guess I was kind of curious as to where it drops off. You know, where do people sort of stop connecting with sort of the importance of earth science? Potentially it's at school. I know that sort of in some of the programs here in high school in Australia, things like geology are not formally taught at sort of that sort of upper high school level. So I guess, you know, as our role as early career professionals or mid-career researchers in this particular panel, our job really is to go out and make sure that we're doing the outreach, you know, the connecting with the next generation. And I know that I've certainly been invited to give talks, you know, sort of to that sort of late teen, early sort of 20s kind of age range, and sort of talking about the importance of geological skills in that transition to that sort of greener energy future has actually really connected. I remember I gave a talk at I guess it was a geoscience industry mixer night, and you know, all of the students were just flocking around my table. They weren't going to like the Rio Tintos, the BHPs talking about summer opportunities. They were flocking around my table because they really wanted to engage with how their skills could be a part of a better future. And so I think, you know, things like this are important in doing that, but certainly it's each and every one of our responsibility to make sure we make time in our schedules to go and do that outreach.
Yep. So Grace, how about you? You're really close to this, and it's obvious that you are passionate about what you do and you're excited about the opportunities. How do you translate that to your peers and to some of the students you recently were in school with?
I definitely think education is the important bit. So it's something about me is I didn't really have a background in graphite. That wasn't something I specifically studied in school. I kind of just stumbled upon the subject and did a research binge, did a lot of reading about it. And that's really what got me interested in it and got me working at AETC. And so it wasn't really something on my radar beyond that graphite is in pencils. Sort of when I bring up graphite, I have to preface it with saying, oh yeah, it's the material that is in pencils. So I definitely think it's education, that really getting it into people that this is something important and how it directly impacts them at a personal level. So it's got to be the education.
Thanks, Grace. Right, I'm going to come back to you, but we're about to lose Alex. So Alex, I'm going to ask you not only for your last word, but if you're saying that, you know, we have got to get these smart minds to move from recycling projects to the mining part of and the processing part of the supply stream, how do we do that?
So I do this all the time because I need to find people to work on projects that I'm involved with, and I try to attract them so they'll reach out to me. So there's kind of an activation energy for people to send a cold message on LinkedIn if they don't know me already, right? Anyone who's moderately crazy enough to do that, almost always I will take an intro call if I look at their LinkedIn and I'm like, okay, you know, interesting background, because I want to help people. I don't spend any time doing like, you know, dedicated outreach. I just look for people who kind of pass that bar of craziness to just do something as basic as that. And then pretty much for like everyone else, I just tell them like, don't be afraid like, that's what I tell people over and over and over again. I find myself saying is like, so many people are afraid of failure or afraid of like looking silly, or I don't even know anymore, because I've so thoroughly vanquished fear of these things in my own head. So like, I can't even relate anymore. But like, I just tell people all the time, don't be afraid. Try new things, fail and learn. And don't like sequester your potential because like there isn't yet a narrative for you to, create value, like doing things that you think you can create value doing. Like I should not be able to do the things I'm doing right now. Like it just doesn't make any sense. Like I'm 29 years old, running multiple very successful consulting companies. And I've never even worked at a lithium company. So, and it's just because like I was not afraid to look silly or to fail. I could have failed, but I just didn't. So yeah, just like people should not be afraid. And if there's any way I can ever help, let me know. People have my contact info. So yeah, and then like another part of it is like I go hunting too, like because I really put a lot of time into thinking about how to kind of elevate women and people of color and queers to make them successful, because that's the only way to like we need to like steal the money from the old straight white men and then like use the money to like buy disco balls and like elevate other queer female people of color, etc. And we just need to compete with them, like not spend our time talking about being women, queers, and people of color, but just by going and doing it, So I spend all my time just like doing it, to make the money instead of some stupid old straight white man. Anyways, so that's kind of some of the radical politics doing underneath of my thesis and my work. Not even that radical. But yeah, so anyways, so I go hunt down people who fit that bill, who I think could be successful and who are crazy. Like I need to find crazy people who are not afraid, So I encourage you all to be crazy people who are not afraid. Yeah, but I do have to go now, so sorry.
I know we have to say goodbye. I just want to let you know before we continue the discussion, I just posted my favorite quote from Dune in the chat, which is "Fear is the mind killer." So thank you for leaving us with that. Don't be afraid. Yeah. Thanks, Alex.
Don't be afraid. Bye.
Bye. So Anita, you wanted to say something.
No, I was intrigued by Alex's final words. That was always a comment to Alex. But yes, no, certainly. Yeah, I do agree with him that certainly fear is not something that should hold us back, and we should be courageous and move forward. That's great. Yeah, I was interested what the glitter ball was going to do to help women of colour, but there we go. Maybe we'll save that for another time.
Well, I encourage you to reach out on LinkedIn. And again, I will say I've got a few more questions out here, and I'm going to revert to you, Lauren, to answer the last one. But I also have posted again everyone's LinkedIn contacts, and I just want to re-emphasize we still have another 20 minutes of Q&A. But if you don't have a chance to get your question answered, if you don't like the answer, or you disagree with the answer you get, or you have a continuing conversation with one of our panelists, they are all willing and eager to engage outside of this meeting. As a matter of fact, we sort of view this discussion as the equivalent of a first cup of coffee, and hope that it will engender one or two continuing relationships and conversations. So Lauren, I've forgotten the question that I was asking you, but you will have remembered it.
Asking me about getting emerging geoscientists into the field.
Excellent.
This is something that's really passionate for me. So I studied in both Australia and the UK, and my geology degree in Australia was really different to the geology degree in the UK. And the focus in the UK was much more on environmental geoscience, whereas the focus in Australia when I was going through, which was, I started almost 15 years ago. So the focus in Australia was really hardcore mining, but linear mining. So take, make, and waste. And I think it's shifting, but as we can see from COP26, maybe not shifting quite as quickly as we would like it to be shifting. I think that there is a huge disconnect because people see mining as this dirty industry, and they don't understand that if you understand the principles of mining, if you have experience in mining, then you can apply this from the inside and make a difference to work your way out. So that has always been my plan. My plan has always been to work in mining for years. I wasn't expecting to do it for 10, but to work in mining and then to be able to use that skill and that knowledge that I have of how the processes work, how business decisions are being made, to be able to then transition this to a more environmentally sustainable way of doing things. So I think the onus is really on us. The onus is on the scientists and on the mining industry professionals that are doing cool things in the industry to be able to share it with young professionals. So, I mean, I know at UQ, and this is no criticism of UQ, but the geoscience group at UQ, they hold industry nights. And a lot of the time, they don't include the other institutes like SMI. So Anita went to one this year, and as she said, her table was full of people because they were so excited to learn about what our team is doing. But previously, I certainly know from the industry nights that I have been to, there hasn't been that representation of many different groups in industry, many different technologies being exposed there. So I think, yeah, it's on us to be able to reach out to universities and also to high schools and say, hey, this is a cool industry to be part of, and you can use these skills to be able to make a difference and make the environmental footprint a lot smaller, and to be able to transition the industry into more circular economy principles rather than the linear mindset that we've got at the moment. Yeah, that's my 2 cents. Oh, you're on mute.
There we go. Now that I have unmuted myself and I have finished off that question, we have another question from a former panelist and another question from an audience member that I will ask to all of the 3 of you remaining. And the question comes from one of our former panelists last summer, Dr. Igor, and his question for everyone is, 95% of lead acid batteries are currently recycled in the US. 25% of alkaline batteries are currently recycled in the US. Should we, and I would add, when might we expect similar trends with waste lithium ions? Grace, I'm going to ask you that one first.
Yeah, so I guess, I mean, I do believe that we should expect a similar trend. I know there's not a lot of lithium-ion batteries being recycled right now, and I know, again, it's been stated that it's really the cobalt and the nickel that's being recycled, but I think that there's definitely a trend coming, especially as we're recently signed the Paris Agreement, and I think there's some societal pressure when it comes to we need to be greener, we need to do these more sustainable practices because we could be facing even bigger crises in the future. So I definitely think there's going to be that trend. How soon, I'm not quite sure. So I think we need to be doing a lot more groundwork now so that we can be prepared for when we really need to have all these materials be recycled.
It is something that we're not used to. We're used to blowing up our energy storage device and turning it into carbon dioxide. So it's really almost more of a business model and a mindset change, isn't it, than really a technical change. So Anita, your thoughts on maybe when and what it will take to get us to that same level of recycling for lithium ions?
I mean, I guess I probably agree with what Grace was saying, but I guess I was in some ways I was a little bit distracted by Igor's follow-up question in the chat, which was recyclers of lithium-ion batteries. Sorry.
Go for it. Maybe you can read that out for us.
He was asking recyclers of lithium-ion batteries, and mainly after cobalt and nickel, what would you do to ensure that there is still an incentivization to recycle batteries commercially when an alternative chemistry is found, which doesn't use nickel or cobalt? But I guess I just wanted to make the point that I suppose, whilst this chat has been focused on batteries, I mean, if you think back to some of the graphics from the visual capitalists who do the most awesome graphics in the world, and those are actually really important to share with students when you're trying to get people into, thinking about circular economy and valorization, because those graphics, they capture so many sort of aspects of like energy transition really perfectly. So I always show things like that. But certainly in one of their graphics, and they sort of talk about the different green technologies where cobalt is used. I mean, it's nuclear power, it's, and I'm looking at it right now, I should probably just share my screen. Nuclear power, EVs, carbon capture and storage, so many different things that we need the cobalt and the nickel for. So I suppose whilst this chat is focused on the batteries, there's so many other technologies which will use these materials. So still worth reprocessing and recovering from, e-wastes, mine wastes, landfill leachates, wherever you can look. AMD
Great.
Directly, so many sources. So I was a little bit distracted by that second question.
No,
Sorry,
no problem. No problem. That was going to be one of my follow-ups, but you've taken care of that. That's okay. Lauren, what do you see as the time frame for when we can begin to add recycled components to the supply stream?
So I was looking at the outcomes of COP26, and I think it's really important. I know that there's a fair amount of bad press that is going around about it, but I also think that we need to look at the positives that have come out of global leaders getting together and having a common goal. But one of the pledges that came out of it was to be able to phase out coal, but then to transition to electric vehicles, and transport was a really big topic that was talked about there. And so a lot of governments have looked at how they're going to transition to electric vehicles and transition to low carbon emissions in the transport space. And I think that this is going to really drive battery technology, which will mean that we will have so many more, just by cause and effect, we will have so many more batteries that will be used, and therefore recycling of it is going to have to become a key priority for our governments, because otherwise we're going to end up with huge amounts of landfill that we don't know what to do with. And it's the same problem with mine waste. We've got huge amounts of mine waste, and we have to do something about it because it's causing environmental issues. So I think just directly by cause and effect, as governments are moving towards an energy transition in transport in particular, that we are then, by 2030, definitely by 2050, we are going to have to start recycling these batteries. Otherwise, we're going to end up with far more issues in terms of waste management.
Got it. Yeah. So I have one more question for each of you that's a little off topic, but I'm going to ask it anyway. And then I'm going to ask each of you to give just a last summary thought, one last thought to leave with everyone. And then I have a few more summary slides at the end. But the question I'd like to ask you, and again, I know it's maybe not your primary area of interest, but what do we not see coming in terms of battery chemistry and battery technology? What is down the road? What do you think is going to happen, say, 10 years from now that might upset the apple cart in terms of lithium ion batteries being the bog standard storage device? I mean, are we going to see gravity storage? Are we going to see hydrogen? What are the crazy things that could happen in the energy storage world from your perspective and from what you've read? Let's see, Anita, you want to take this one first?
Yeah, sure. I don't feel too well versed in this space, I must admit, but certainly listening.
That's why I asked the question. Sometimes it's the people who are looking at it with new eyes that see the most interesting things.
Well, I don't know about that. Well, you can tell me in 2 minutes' time. I guess, certainly in Australia, there's been a lot of chatter around sort of hydrogen. So, I mean, maybe that's the next big thing coming when we go to sort of these Queensland Exploration Council forums and so forth, and there's been that sort of big chatter around hydrogen, so maybe that's the next big thing. I'm sure that there's going to be sort of permitting, regulation, environmental issues associated with that too. But certainly that seems to be where a lot of the big push is going to be. I think if I was just going to change tack a little, I mean, in terms of some of the challenges we have here in Australia, and we think about the energy transition, and certainly we have a great deal of metallurgical coal mines in Queensland, but certainly as we move towards sort of our Victorian states, it's sort of coal for other purposes, as it were, for the power stations. I mean, we do have potentially an energy crisis on our hands in terms of some of those coal mines down there are going to stop operating in the next sort of decade or even sooner. But what do we do? I mean, Victoria sort of rely heavily upon that, the coal for their power. So I guess there's probably a debate that's going to become bigger in Australia around bigger scale power, and that's probably around uranium. So I think I'd be interested to see what happens in the space of uranium in Australia. I know that certainly in Queensland, in the state of Queensland where Lauren and I are, uranium mining is not permitted. So I'm curious to see also how that conversation and that sort of thing develops in the next 10 years or so. So that was changing tack a little bit, but yeah, hydrogen,
No
uranium.
problem. No problem. And I'm going to ask our other two panelists the same question. And then I have one more topic actually that's coming from our attendees that I'll get to before we wrap up. So Grace, your thoughts on what's the next best, newest, weirdest thing?
Oh, I mean, I don't know about so much for the weirdest, but I know there's, I've been reading about sort of how we can make batteries sort of more efficient when it comes to additives and different using silicon in batteries and how that can make things more energy efficient. So I don't know if that would be the weirdest thing, but there's some interesting research that is happening right now that I've been reading about.
Fair enough. Yeah, we talked about a little bit of that in our last episode for sure. So Lauren, anything that you have found that's new and fascinating on the horizon?
I think, and this is an area that I'm not very knowledgeable in, but I think that digitization and AI are going to play a pretty large role in technology as we move forward into the future. I think that the people that do that kind of work are incredibly smart, and I'm in awe of them. I'm definitely not one of them. I'm much more in the traditional geoscience space, but yeah, I think that that's where we're going to make some really big differences, because the amount of work that you can actually get done when you do deep machine learning and AI processes it is spectacular. I also think that, like you were talking about the challenges that we're going to face, with lithium-ion batteries and things like that. I think that it's really important for things. I mean, I don't want to continue to talk about COP26, but I think it's really important for governments to start to think about less about their internal needs and desires and more about what's best for our globe as a whole. And I think that it's really important that we're transitioning to that space now, and it's being driven by science, which is really exciting. So I hope that the community attitude shifts more towards this space to be able to make it possible to have an energy transition. Yeah, that's what I'd like to contribute.
You're tugging on my heartstrings with that one, because one of the big benefits that I see to using renewable distributed energy resources is the actual opportunity to approach something resembling energy equity on a global basis. And I think that's something we can all get behind and work toward as we sort of change our mindset from extracting value to providing value. And I think that will be an interesting, I wish I were 40 years younger so that I were sitting where you were to watch that. So I have one more question. Sorry,
I just wanted to say something on that. I definitely think that helping developing economies and our responsibility as developed nations to do that is so significant in this space, because the developing countries have so much of the world's population there. And so, I mean, the decarbonisation story really needs to focus in their contribution as well and how we can assist. And so, yeah, I think equity in energy is super important to talk about.
And the beauty is that so much of what we're doing in the renewable energy space actually works better in the environment of densely populated areas in need of electrification. So yeah, there's a lot of reason for hope there. So I'm going to quickly ask this question from our audience, which really revolves around, there's several questions out there, but in general, it's what about recycling things other than batteries? Do any of you have comments on recycling electronics to provide some of the critical materials, recycling? There's a comment here about catalytic converters that are increasing palladium platinum recovery. But you know, cell phones, computers, electronics, are these reasonable or possible sources of some of the critical minerals we need for the energy transition? And I'll just throw that open. Would anyone like to raise their hand and answer?
Of course. I think, of course, every element that's being mined out of the earth and then gets created into something of use that we're using can then be repurposed and recycled, I think. So yeah, I think electronics and computers and everything else that we use in our daily lives can be recycled. Maybe that's me just having a utopian view of the world, but I very much believe that that we need to transition our thinking into this recycling mindset. I know that Alex was saying that, you know, recycling is not going to secure the supply of critical metals for what we need in the next, you know, however many years. But I was reading an article the other day that said that if we just continue to use critical metals as a finite resource and just continue mining, we're going to be using something like 400 times the capacity of the earth to be able to do that. So we're going to have to start looking at recycling options for all sorts of different equipment and technologies and things that we have in our daily lives and big industry has in their lives. I mean, the number of times that I've gone to an abandoned mine site, in exploration, we go to a lot of old sites that then we're looking at with fresh eyes, and so we're revamping them. But because I'm going to these old sites, I see the amount of equipment that is still left there and abandoned there, and I think, oh my goodness, we can repurpose this equipment. We can reuse it. There's so much of it and it's just sitting there rusting. So yeah, I think that there is big opportunity in that space that we can use.
Okay, well, panelists, our time has come for final comments, and then I have just a few wrap-up remarks. So I'm going to ask each of you, you know, in 30 seconds or so, if there's one thought that you could leave our attendees with after the conversation we've had today, what would that be? And I see, Anita, you are unmuted, so I'm going to pick on you. What would your final thought be?
Excellent. Yeah, well, first, thanks for everyone for attending this panel today and for the invitation, Edith. But I guess the final thought I wanted to leave you with, like, I guess when we talk about recycling, repurposing across all different waste industries, I don't think the barriers are technological. I think they're social and they're political. I do think there's a lot that needs to be done. I mean, I think COP26 was great, but you know, the Paris Agreement was also great all those years ago too. So I guess needing to actually see a lot of the chatter, every single politician got up and said the same piece. It's probably the same piece we're saying today, but I want to see that chatter become action. You know, in terms of young people, we've got people like Greta Thunberg, and she's great in terms of a young activist, but I don't understand when I look at my son's friends, why they're not all engaged with this amazing young role model that they have. So, you know, I do think a lot of the responsibility in terms of, you know, bringing earth sciences and sort of, you know, recycling, circular economy, everything we're talking today about, bring it to the fore is on all of us. We do have to sort of improve our messaging, but certainly I don't think the barriers are technological at all. I think there's a lot of smart people, there's a lot of smart technology out there. We can do it. It's like when I say to my kids, tidy your room. Just tidy your room. Just keep it the same. Tidy your room every day. Same thing. Tidy your room. Keep it tidy. As adults working in this industry, across all industries, we know what we need to do to tidy it. Can we be bothered? That's kind of the question. Now, you know, we need to stop being lazy. The technology is there. We need to change the policies. You know, maybe it needs to be regulated that you will do this. You must do this. Like, you know, when I say, give my kid a list saying this is what you've got to do, then he does it. So, you know, maybe that's part of the problem. But certainly, I think it's a lot around the social, the policy, the messaging. I don't think the barriers are technological here at all. The Earth's been recycling metals for decades. Since it was born, the Earth's been recycling. So, you know, come on, get with the program, humans. Yeah.
I love that. It's not about the technology, it's about social and politics. Excellent. Grace, your final thought to leave with the group.
Yeah, so I guess I think we should be trying to recycle as much as we can. I mean, we don't want these valuable materials, minerals, just being in landfills that can then the casings can corrode and it could cause environmental damage. We don't want that sitting out there. And so I think we should be really trying to recycle as much as we can and to design products so that they are more easily recyclable. That's another thing with some of these batteries, that they're so complicated that it's difficult to recycle with them, and that we should be focusing on recycling all of the materials as much as we can, and not just what's considered valuable, the nickel and the cobalt, but looking at all the materials, and including graphite. And I definitely think, like Anita said, we need to be doing this now, and we really need to be taking action now, so that we have the ability to ramp up as global demand and all these more of these devices are going out there into the world. That will be ramping up, so we need to be starting this now.
All right, I love it. Design for recycling and start now. Lauren, final words.
It's a bit of a responsibility being the last one to give final words. I'm glad you're speaking after me, Edith.
Oh, of course.
I should ask you the same question. What are your final thoughts on this? So my space is in mine waste, and there's a huge issue with mine waste. We have 100 billion tons of mine waste being generated per year globally. And so this is the largest amount of manhandled material that we're dealing with, and we need to do something with it, and we can do something with it. Really exciting, but we just have to shift this attitude from linear mining to circular economy in mining. And I don't think we're there yet. I think that it will really take some game changers, some people with attitude changes to be able to do this. I know from working in industry that really the economic driver is the big one, that we need to make this an economic perspective to be able to make it worthwhile for private companies and industry to want to do it. And so that's what my PhD is about, is economic rehabilitation. We're not just doing this for the environmental and the social responsibility, which I think is the most important thing, but for a company, for a business, the economics is really important as well. So let's try and find a way to merge these ideas together to be able to make money from it, but also have a really positive environmental impact. So.
Excellent. Gosh, I think, Duncan, you have some quotes from all of our panelists that are wonderful, from linear to circular, having a commercial impact, designing for recyclability, and worrying about the social and political as well as just the technical. Thank you all very much for that. Deanne, if you would put up our last slide, we will take her home. So before we close the curtain on critical minerals, I do want to take just a moment to remind you of an upcoming SEG event. 1 week from today, our distinguished and traveling lecturers are providing a virtual symposium that showcases their talks and offers another great opportunity. I sat in on the last one of these. They are fantastic for the audience worldwide to engage with our distinguished lecturers. Each lecturer will provide a 45-minute presentation followed by a question and answer session. And these are globally recognized individuals that serve as ambassadors for our society. So I really encourage you to attend if you haven't already seen them. The lecturers are excellent speakers, and they're selected each year based on their significant contributions to the field of economic geology. So please join us as we wrap up the year and get ready for an exciting 2022. Next slide, please. All of these events, by the way, are on our segweb.org website, and you can register for all of these events. So my next to the last slide is a huge and heartfelt thank you to all of our panelists from throughout the year, including those of you who joined us today. If you missed an episode or you'd like to listen in again, remember you can find all of this year's episodes archived on our website. As Margaret Mead said so eloquently, and this is my favorite quote, never doubt that a small group of thoughtful and committed individuals can change the world. In fact, it's the only thing that ever has. And I want to say to each of you from the bottom of my heart, thank you for changing the world, one person, one conversation at a time. So our last slide, we've come to the end of 2021, but not the end of SEG's webinar series. And in light of some of the comments that were made, particularly by Lauren, I'm pleased to announce that in 2022, mining geologist Maureen Moore will guide a deep dive into innovative exploration technologies. So stay tuned for more information on that. And be sure to fill in the feedback survey, which will pop up as you log off. Especially before I close for good, a big thank you to all of our diverse attendees who asked great questions and made these sessions worthwhile for each of us on this side of the screen. So thank you and goodbye.